Hello students, welcome back to this lecture on triangles in NCERT Exemplars. Okay, so in this lecture we will discuss from this question. So in this question it said to us in figure BD, in this figure BD and CE intersect each other at the point P. Okay, and it asks to us if triangle PBC is similar to triangle PDE, and if it is similar then why it is similar. Okay, so we have given this figure here. The length of BP is 5 centimeter and the length of P is 12 centimeter, length of CP is 6 centimeter, and the length of PD is 10 centimeter. Okay, so let us solve it step by step. So in triangle PBC and triangle PDE, here the angle BPC, this is equal to angle EPD. Okay, so they are equal since vertically opposite angles there. Okay, so now here PB by PD, this is equal to 5 by 10 and this is equal to 1 by 2, and naming this equation number 1. And now PC by P, this is equal to 6 by 12 and this is equal to 1 by 2, and naming this 2. And now from equation 1 and 2, here PB by PD is equal to PC by PE. Okay, so this ratio, these two ratio PB by PD is equal to PC by PE. So since one angle of triangle PBC is equal to the one angle of triangle PD and the sides including these angles are proportional, so both triangles are similar by side angle side similarity criteria. Okay, so hence triangle PBC is similar to triangle PDE. Okay, so these two triangles are similar to each other. Now let us move to next question. So in next question it said to us in triangles PQR and MST, here angle P is 55 degree, angle Q is 25 degree, and angle M is 100 degree, and angle S is equal to 25 degree. And it asks to us is triangle QPR is similar to triangle TSM. Okay, and if it is similar then why it is. Okay, so now let us solve it. So we know that the sum of the three angles of a triangle is 180 degree. Okay, so in triangle PQR, here the angle P plus angle Q plus angle R is equal to 180 degree. And here we have given angle P is 55 degree, angle Q is 25 degree, then we can easily find the angle R, that is equal to 180 degree minus 55 degree plus 25 degree, that is equal to 180 degree minus 80 degree, that is equal to 100 degree. Okay, so now in triangle TSM, here the sum of three angles of this triangle TSM is equal to 180 degree. Okay, so here angle T plus angle S plus angle M, this is equal to 180 degree, and here we have given angle S is 25 degree and angle M is 100 degree. So now angle T is equal to 180 degree minus 25 degree plus 100 degree, that is equal to 55 degree. So angle T is equal to 55 degree. So if you see this figure, so angle Q is 25 degree, angle P is 55 degree. Okay, and we find the angle of R is 100 degree. Okay, and here angle S is 25 degree, angle M is 100 degree, then we find the angle T is 55 degree. Okay, so in triangle SM, here angle P is equal to angle T, here angle Q is equal to angle S, and angle R is equal to angle M. Okay, so their corresponding angles are same. Okay, so it implies their corresponding sides are in same ratio. Okay, so by using the basic proportional theorem, okay, similarity criteria. Okay, so therefore triangle PQR is similar to triangle TSM. Okay, so since all corresponding angles are equal, so hence triangle QPR is not similar to triangle TSM. So since the correct correspondence is P to T, Q to S, and R to M, so that is triangle PQR is similar to triangle TSM, but triangle QPR is not similar to triangle TSM. Okay, so triangle QPR is not similar to triangle TSM. Now let us move to next question. So in next question, it said to us, is the following statement true? Okay, is the following statement true or not? So why? Two quadrilaterals are similar. Two quadrilaterals are similar if their corresponding angles are equal. Okay, so let us see, is this following statement true? So here the following statement is false. Okay, so two quadrilaterals are similar if their corresponding angles are equal and their corresponding sides must also be proportional. Okay, then two quadrilaterals are similar. But here in this question, here basically we have given their corresponding angles are equal, but their corresponding sides, there does not given to us the information about their corresponding sides. Okay, so this statement is a false statement. And now let us move to next question. So in next question, here it said to us, two sides and the perimeter of one triangle are respectively 3 times the corresponding sides, and the perimeter of the other triangle. Okay, so are the two triangles are similar, and why? So here in this question, it said to us, two sides and the perimeter of one triangle are respectively 3 times the corresponding sides and the perimeter of the other triangle. Okay, so let us see. Here this statement is also, this statement is actually true statement. Okay, so here the corresponding two sides and the perimeters of two triangles are proportional. Then third side of the both triangles will also in proportion. So this statement is basically a true statement since the corresponding two sides and the perimeters of two triangles are proportional. Okay, then third side of the both triangles will also in proportion. And now in next question, here it said to us, if in two right triangles, one of the acute angles of one triangle is equal to an acute angle of the other triangle, can you say that the two triangles will be similar? Okay, can you say that two triangles will be similar, and why? So let us see answer. So here the statement is true. Okay, so here these two triangles are similar. Okay, so let us see why these two triangles are similar. So let two right angle triangles be triangle ABC and triangle PQR. Okay, so we have these two right angle triangle. So here in which angle A is equal to angle B, that is actually 90 degree, and angle B is equal to angle Q, this is equal to acute angle. And then by angle similarity criteria, triangle ABC is similar to triangle PQR. Okay, so triangle ABC is similar to triangle PQR. Now let us move to next question. So here in next question is said to us, the ratio of the corresponding altitudes of two similar triangles is 3/5. So is it correct to say that ratio of their areas is 6/5? Okay, so this is false. By the property of area of two similar triangles, that is area of 1 by area 2, this is equal to altitude 1 square by altitude 2 square. Okay, altitude 2 square, and here area 1 by area 2 is equal to 3/5, and this is equal to 9 by 25, that does not equal to 6/5. Okay, so the given statement is not correct. Now let us move to next question. So in next question, if D is a point one side QR of triangle PQR such that PD is perpendicular to QR, will it be correct to say that triangle PQD is similar to triangle RPD, and why? Okay, so D is a point one on side QR of triangle PQR such that PD is similar to QR. Now it asks to us, will it be correct to say that triangle PQD is similar to triangle RPD? Okay, so let us see the answer. So here the statement is false. So in triangle PQD, and triangle RPD. Okay, so here PD is common side in both triangle. Okay, so PD is equal to PD, and here angle PDQ and angle PDR are equal, common side. Okay, so each is 90 degree. So here no other sides or angles are equal. We can say triangle PQD is not similar to triangle RPD. Okay, so now let us move to next question. So in this figure, if angle D is equal to angle C, then is it true that triangle ADE and triangle ACB they are similar or not? Okay, so triangle ADB, is it true that triangle ADE is similar to triangle ACB, and why? So here this is true in triangle ADE and triangle ACB. Here angle A is equal to angle S, then since they are common angle, and angle D is equal to angle C, that is given to us. Okay, so by angle similarity criteria, triangle ADE is similar to triangle ACB. Okay, so now let us move to next question. So it asks to us, is it true to say that if in two triangles an angle of one triangle is equal to an angle of another triangle, and two sides of one triangle are proportional to the two sides of the other triangle, and then the triangles are similar, and give reasons for your answer? Okay, so let us see the answer. So here the statement is false, because according to SAS similarity criteria, if one angle of a triangle is equal to one angle of the other triangle and the side including these angles are proportional, then two triangles are similar. Okay, so here one angle and two sides of two triangles are equal, but this sides not including equal angle, so given statement is not correct. Okay, so now let us discuss this question. So in this question here, given this figure, so if angle A, this is equal to angle C, and AB is equal to 6 centimeter, BP is equal to 15 centimeter, and AP is equal to 12 centimeter, and CP is equal to 4 centimeter, then find the length of PD and CD. Okay, so we have to find the length of PD and CD. So here in this question we have given angle A, this is equal to angle C. Okay, and the length of AB is equal to 6 centimeter, the length of BP is equal to 15 centimeter, and AP is equal to 12 centimeter, and CP is equal to 4 centimeter. So in triangle APB and triangle CPD, here angle A is equal to angle C, and here angle APB is equal to angle CPD, since they are vertically opposite angles, and we know if we have vertically opposite angles, actually they are equal. Okay, so now by angle similarity criteria, this triangle APD is similar to triangle CPD. Okay, so now using the definition of similar triangles, so here AP by CP is equal to PB by CPD is equal to AP by CD. Okay, and the value of AP is 12 centimeter, CP is 4 centimeter, and the value of PB is 15 centimeter, the value of AB is 6 centimeter. Okay, so 12 by 4 is equal to 15 by PD, this is equal to 6 by CD. So one taking first two terms, so we get the value of PD. Okay, so PD is equal to 4 into 15 by 12. So we get PD is equal to 15 into 4 by 12, that is equal to 5 centimeter. And one taking the first and last term, that we get 12 by 4, this is equal to 6 by CD, and it implies CD is equal to 6 into 4 by 12, that is equal to 2 centimeter. So hence the length of PD is equal to 5 centimeter, and the length of CD is equal to 2 centimeter. Okay, so now let us move to next question. So here in this question, it said to us, it is given that triangle ABC is similar to triangle EDF such that the length of AB is equal to 5 centimeter and length of AC is equal to 7 centimeter and length of DF is equal to 15 centimeter and length of D is equal to 12 centimeter. Then we have to find the length of the remaining sides of the triangle. Okay, so here we first think about the approach of this question. Okay, so how to solve it? So here we use the property of the similar triangles, that is their corresponding sides are in the same ratio, and then simplify. Okay, so here given triangle ABC is similar to triangle EDF, so the corresponding sides of triangle ABC and triangle EDF are in the same ratio, that is AB by ED, AB this side by this side, this is equal to this side divided by this side, and this is equal to this side divided by this side. Okay, so AB by AD, this is equal to AC by EF, this is equal to BC by DF. Okay, I'm naming this equation number 1. And also AB is 5 centimeters, AC is 7 centimeter, and DF is 15 centimeter, and DE is equal to 12 centimeter. So one putting these values in equation number 1, we get 5 by 12 is equal to 7 by EF. This is equal to BC by 15. So one taking the first and second terms, we get the value of EF. So EF is equal to 12 into 7 by 5, that is equal to 16.8 centimeter. And one taking the first and the third terms, we get 5 by 12, this is equal to BC by 15, and it implies BC is equal to 5 into 15 by 12, that is equal to 6.25 centimeter. Okay, so hence length of the remaining sides of the triangles are EF is equal to 16.8 centimeter and BC is equal to 6.25 centimeter. Okay, so now let us move to next question. So in this question, we have to prove that if a line is drawn parallel to one side of a triangle to intersect the other two sides, then the two sides are divided in the same ratio. Okay, so let us prove it. So here we first let a triangle ABC in which a line DE is parallel to BC intersects AB at D point and AC at E point. Okay, so we have suppose this triangle, and here we have drawn a line DE. This is our ABC triangle, and this line is DE. So this line intersects at AB at point D and AC at point E. Okay, and now to prove that DE divides the two sides in the same ratio. Okay, so that is AD by DB is equal to AE over EC. Okay, so we have to prove it. So here you can see this figure. So by construction, join BE, we join BE, CD, and draw EF, which is perpendicular to AB, and DG, which is perpendicular to. Proof here, area of triangle AD by area of triangle BD is equal to half into AD into EF by half into DB into EF. Okay, so since area of triangle, this is equal to half into base into height. Okay, so this is equal to AD by DB, and naming this equation number 1. And similarly, area of triangle ADE by area of triangle DEC, this is equal to half into AE into GD by half into EC into GD, that is equal to AE over EC. Okay, and naming this 2. And now from since triangle BD and triangle DEC lie between the same parallel line D and BC, okay, and on the same base D, so area of triangle BD, this is equal to area of triangle DEC. Okay, and naming this 3. So now from equation 1, 2, and 3, we get AD over DB, this is equal to AE over EC, hence proved. Okay, so now let us move to next question. So in next question, here in this figure, if PQRS is a parallelogram and here AB, this side, is parallel to PS, then prove that OC is parallel to SR. Okay, so we have to prove OC, this is parallel to SR. Okay, so we have to prove this. So let us prove it. So we have given that PQRS is a parallelogram. So here PQ is similar to SR, PQ is similar to SR, and PQ is parallel to SR, and PS is parallel to QR. So also AB is parallel to PS. Okay, so that is given to us. So now to prove OC is parallel to SR. Okay, so in triangle OPS and triangle OAB, here PS is parallel to AB, and angle POS, this is equal to angle AOB since they are common angle, and angle OSP, and this is equal to angle OBA, they are corresponding angles. Okay, so now by angle similarity criteria, therefore triangle OPS is similar to triangle OAB. So then PS by AB is equal to OS by OB, and naming this equation number 1. Okay, so now in triangle CQR and triangle CAB, here angle QCR is equal to angle ACB since they are common angle, and therefore angle CRQ is equal to angle CBA since they are corresponding angles. So then triangle CQR is similar to triangle CAB. Okay, so it implies QR by AB is equal to CR by CB, and naming this 1. So now PS by AB is equal to CR by CB. This is since PQR is a parallelogram, so PS is equal to QR. So from equation 1 and 2, here OS by OB, this is equal to CR by CB, or OB by OS, this is equal to CB by CR. So now if we subtracting 1 from the both sides, then we get OB by OS minus 1, this is equal to CB by CR minus 1, and it implies OB minus OS by OS, this is equal to CB minus CR by CR. That implies BS by OS, this is equal to BR by CR. So hence the converse of the basic proportionality theorem, SR, this is parallel to OC. Okay, so hence proved. Now let us move to next question. So in next question, we have a 5-meter long ladder is placed leaning towards a vertical wall such that it reaches the wall at a point 4 meter high, and if the foot of the ladder is moved 1.6 meter towards the wall, then find the distance by which the top of the ladder would slide upwards on the wall. So let us solve this. So here let AC be the ladder of the length 5 meter and BC is equal to 4 meter be the height of the wall which ladder is placed. So if the foot of the ladder is moved 1.6 meter towards the wall, that is AD is equal to 1.6 meter, then the ladder is slide upward, that is C is equal to X meter. So in right angle triangle ABC, here by Pythagoras theorem, here AC square is equal to AB square plus BC square. Okay, so here AC square is equal to AB square plus BC square. So here we have given the value of AC is 5 and the value of BC is 4. Okay, so 5 square is equal to AB square plus 4 square, that implies AB square is equal to 25 minus 16, that is equal to 9. Okay, and it implies AB is equal to 3 meter, and therefore the length of DB is equal to AB minus AD, that is equal to 3 minus 1.6, that is equal to 1.4 meter. Okay, so now AD square is equal to EB square plus BD square. So here we can find the value of EB. Okay, so from this equation, so EB is basically equal to square root of 23.04, that is equal to 4.8. So now EC is equal to EB minus BC, that is equal to 4.8 minus 4, that is equal to 0.8. So EC is equal to 0.8. So you can see this figure, hence the top of the ladder would slide upwards on the wall at distance 0.8 meter. Okay, so this is our final answer. So now let us move to next question. So in next question, for going to a CTB from CTBA, there is a route via CTC such that AC is perpendicular to CB and AC is equal to 2x kilometer and CB is equal to 2 times x plus 7 kilometer. So it is proposed to construct a 26 kilometer highway which directly connect the two cities A and B. Find how much distance will be saved in reaching city B from city A after the construction of the highway. Okay, so let us see how to solve it. So firstly, draw the figure according to the given conditions and use Pythagoras theorem to find the value of x. Okay, so then required saved distance will be equal to the difference of AC plus BC and 26. So here given AC is perpendicular to CB kilometer, CB is equal to 2 into x plus 7 kilometer and AB is equal to 26 kilometer. Okay, so when drawing the figure, we get, if we draw this figure, then we get here AC is 2x kilometer, BC is 2 into x plus 7 kilometer and AC is 26 kilometer. Okay, so here when drawing the figure, we get the right angle triangle ACB, right angle triangle at C. Okay, right angle at C. So now in triangle ACB by Pythagoras theorem, we get this relation AB square is equal to AC square plus BC square. Okay, so now if we put the values of AB and AC and BC, then we get this relation 26 square is equal to 2x whole square plus 2 into x plus 7 whole square. Okay, and if we simplify it, then we will get this quadratic equation 8x square plus 56x minus 480 is equal to 0. Okay, now if we dividing by 8, then we get x square plus 7x minus 60 is equal to 0. Okay, now if we splitting the middle terms, then we can factorize this quadratic polynomial. Okay, so this implies x plus 12 into x minus 5 is equal to 0. Okay, so it implies that either x equal to minus 12 or x equal to 5, but distance cannot be negative. Okay, so x can be 5. So now the distance AC is 2 into x, that is 10 kilometer, and the distance BC is equal to 2 into x plus 7, that is equal to 2 into 5 plus 7, that is equal to 24 kilometer. Okay, so this distance AC is 10 kilometer, this distance BC is 24 kilometer. So the distance covered to reach CT from CTA via CTC is equal to AC plus BC, that is equal to 10 plus 24, that is equal to 34 kilometer. And distance covered to reach CTB from CTA after the construction of the highway is equal to BA, that is equal to 26 kilometer. Okay, so hence the required step distance is 34 minus 26 kilometer, that is equal to 8 kilometer. Okay, so now let us move to next question. So in next question, it said to us a flagpole 80 meter high casts a shadow 9.6 meter long. Find the distance of the top of the pole from the far end of the shadow. Okay, so let us solve it. So here we let BC is equal to 18 centimeter. So here we let this is 18 meter. Okay, be the flagpole and its shadow be AB is equal to 9.6 meter. And the distance of the top of the pole, that is C from the far end, that is A of the shadow is AC. Okay, so here in right angle triangle ABC is by Pythagoras theorem AC square is equal to AB square plus BC square. So it implies AC square is equal to 9.6 square plus 18 square, and it implies AC square is equal to 92.16 plus 324. And it implies AC square is equal to 416.16, and it implies AC is equal to square root of 416.16, that is equal to 20.4 meter. So hence the required distance is 20.4 meter. Okay, so I stop here this lecture. Thank you very much to all of you.